All right. So now here we talked about, or today actually, we're going to continue talking about estimating roots. We started estimating roots before the spring break. So we're going to do estimating roots today and simplifying roots today. That's what we're going to cover. All right. So in estimating roots, we're going to remember from the previous week before spring break, we talked about square root, or finding the square root of a number means that you find one number that can be multiplied times itself to give you the number that's under this radical sign. Okay? That's what it means to find the square root of a number. Now, we did this in our last session when we wrote down all of our perfect roots. These are perfect squares here that are going to help us write down our perfect square roots. I'm going to do the first couple and then you're going to do the others on your own. Let me show you how this works. Your first, well, let's mark this one out because we don't do zero square root. Okay, we don't do square root of zero. All right, so let's start with 1. We know that 1 times 1 is going to give us 1, or 1 to the second power is equal to 1. We know this. Please put that in this column, this first column here. So then what that tells us is this, that the square root of 1, because 1 times itself is equal to 1, the square root of 1 is equal to 1. Okay? Any questions about this? Okay. The next one. Our perfect square root is, or a perfect square is 4. What we know about 4 is that 2 times 2, or 2 to the second power, is equal to 4. Therefore, the square root of 4 is equal to 2. Why? Because 2 times itself is equal to the number under the radical, which is 4. Let's do another one. If I'm moving too fast, please unmute and let me know. Please make sure that you're doing this the same time I'm doing this, so when it's time for us to submit this work, you already have it completed, okay? The next perfect square is 9. And what do we know about 9? We know that 3 times itself, 3 times 3, or 3 to the second power, which is the same thing, is equal to 9. So what does that mean, Ms. Reyes? That means that the square root of 9 is equal to the number 3, because 3 times itself gives you the number under the radical, which is 9. Okay. Let's look at the perfect square 16. How is 16 a perfect square? What do we know about 16? Well, we know that 4 times itself, 4 times 4, or 4 to, again, to the second power is equal to 16. So what does that tell us? That tells us that the square root of 16 is equal to 4. Because again, 4 times itself is equal to the number that's under this radical. Any questions about the first 4 that I've done? I'll do one more and then I want you to fill in the rest of this table, okay? All right. So we have 25. What do we know about the perfect square 25? We know that 5 times itself, or 5 to the second power, which is the same thing, is equal to 25. So that means the square root of 25 is equal to 5, because again, 5 times itself is equal to 25. Okay? So now what I want you to do is I want you to fill out this table. Fill out this table. I'm going to give you about, let's see, I'll give you about 2 minutes to complete the table. If you need more time after the 2 minutes, just let me know. I'm going to pause the video for the calls, okay? Pause for the calls. Any questions before I let you loose? Okay, I'm going to pause for the calls. Okay, this is what you should have here. Okay, please make sure that you go back and watch the video if you need to, because at that time you can pause it or rewind or do whatever. But this is what you should have as the completed table. Questions, comments, or concerns? Okay, we're going to move on to the next page. We're going to move on to the very next page. And it looks just like this. I'm going to pause real quickly to make sure everyone here is okay. All right. So here on this sheet, we're going to do two things. We're going to estimate the roots like we did before the break, and we're going to simplify. So we're going to do both. I'm going to divide these boxes in half because on one side I'm going to estimate, and on the other side I'm going to simplify. Okay? So I'm cutting all the boxes in half. Right? Okay, so let's look at this first one. We're going to do the estimating first on these, and then we'll go back and simplify. If we don't have enough time to do simplifying today, we'll pick up on simplifying tomorrow. Okay, so we're going to estimate. So in order to estimate the square root of 15, we're going to use our perfect squares. So let's go back to the front page, and let's see which one of these perfect squares is the square root of 15 in between. The square root of 15 is in between, look, the square root of 9 and the square root of 16. 15 falls between these two perfect squares. So that's what I'm going to write on my paper. I'm going to write right here the square root of 9, the square root of 16. The square root of 9 is equal to 3, and the square root of 16 is equal to 4. Now let's think about it. Is 15 closer to 9, or is 15 closer to 16? Anybody? Is 15 closer to 9, or is it closer to 16? Okay. Can't open the chat, so just say it aloud because my chat is disappearing. All right, it is closer to 16. So that means, since 15 is closer to 16, that means our answer is going to be about 4. So about, the symbol for about is the squiggly lines, and 4. The symbol for about is the squiggly lines. Instead of the equal, it's squiggly lines. That's the symbol for about. So this is what we rounded to. Okay. All right, so let's look at the square root of 50. Let's look at the square root of 50. Okay. All right, so in order to estimate the square root of 50, we go back to our perfect squares list and see where 50 falls in. Falls between what two perfect squares? So the square root of 50 is between the square root of 49 and the square root of 64. These are the two perfect squares that it is in between. So on my paper, I'm going to write the square root of 49 and the square root of 64. These are the two perfect squares that the square root of 50 is in between. The square root of 49 is equal to 7, and the square root of 64 is equal to 8. So which one is 50 closest to, 49 or 64? Very good, babe. So that means our answer here is about 7, since it's closest to 49. So the whole number that it's closest to is 7. Great job. Any questions so far? Okay. All right, let's look at the next one. 105. Okay, can somebody tell me what two perfect squares is the square root of 105 in between? Can anybody tell me that? What two perfect squares is it in between? It's between, let's go back and look. 105, look at what I'm doing. 105 is not between 1 and 4. It's not between 4 and 9. It's not between 9 and 16. It's not between 16 and 25. It's not between 25 and 36. It's not between 36 and 49. It's not between 49 and 64. It's not between 64 and 81. It's not between 81 and 100 either. But it is between 105 is between 100 and 121. Those are the two perfect squares that it is in between. So we're going to put the square root of 100, which is equal to 10, and the square root of 121, which is equal to 11. Now, is 105 closer to 100 or is it closer to 120? Definitely. Very good. So that means our answer is going to be about 10. Good job. Thank you. Very good. All right. See if you can do this one on your own. What two perfect squares is 130 in between? Okay. What two perfect square roots is 130 in between? Anybody? What two perfect squares? Let's look. Look at your perfect squares. These are your perfect squares here. 130 is not in the middle between these two. It's not between 4 and 9. It is not between 9 and 16. It is not between 16 and 25. It is not between 25 and 36. It's not between 36 and 49. It is not between 49 and 64. It's not between 64 and 81. It's not between 81 and 100. But it is between, which number did I say? 130? It's not even between 101, 121. It's between 121 and 144. Those are the two perfect squares that is in between. That's between 121 and 144. The square root of 121 is equal to 11. The square root of 144 is equal to 12. Is 130 closer to 121 or 144? Let's count. Let's see how far these are. Let's see. We got 121, 122, 23, 24, 25, 26, 27, 28 there, 29. It's 9 away here. And from here to here, it's going to be what? 14. So it's closer to this than it is to this. And all I did was just count. That's it. Which one is it closest to? So this is about 11. Okay. See if you can do these two on your own, and I'm going to pause for the calls, okay? Any questions about estimating before I do simplifying? Okay. All right, I'm going to move on. Now we're going to simplify. We're going to be simplifying in these boxes right beside it, okay? But before we do that, we're going to write how to do that in our notes. So take out your composition notebook. Take out your composition notebook. Okay, guys, please let me know if I'm moving too fast. We're going to take some short notes. This is what we did on page 1, which is what you should already have. If not, please go back and watch the video that we did on that, okay? Page 2, we did estimating roots, and this is what this page looked like because I wrote it in, actually wrote it in this one. Okay, estimating roots. This is what this page looks like. Okay. All right, for estimating roots, there's one thing that we didn't add to our notes that we do need to add, and it's what's in this circle right here. Please write this example on this page. We already did this example on our guided practice today, but I need you to write that example on the page so that when you go back and look at your notes, you'll have an example for this topic. So please write this example down. And I'm going to pause to give you a chance to write. When you watch the video, remember you can rewind, fast forward, pause it, however whatever you need to do. But I'm going to pause for the calls. Page 3, and today's date is 4/12/21. The title of this page is Simplifying Roots. The only way to go about teaching you how to simplify roots into doing notes in this is to actually just do an example with you. Okay. So we have example 1. And tomorrow I'll go back in with you and I'll write in the steps. I'm going to verbalize them today due to time, and then we'll go back and write the steps in tomorrow. And it's 4 steps that we're going to do. So for square root of 100, we already know it's 10, but we're going to go a long way of working out this problem. So the first thing we do is draw a factor tree. So look at me draw a factor tree. That means what 2 numbers can be multiplied to give me 100? And I already know 10 times 10. When I draw a factor tree, just as we did when we were in the 6th grade, we break it down to all prime numbers. 10 is not prime because it has more than just 2 factors. It has other factors other than 1 in itself. So we can break 10 down some more. It's a composite number. When you have 2 or more factors, it's a composite number. You're trying to break the number down to all primes. The 2 numbers that can be multiplied other than 1, cannot use 1 in a factor tree, is 2 and 5. Both 2 and 5 are prime numbers, so we circle them. And we're done breaking down 100. That's the very first step, is to draw a factor tree and circle your prime numbers. The second step, you're going to take all of your prime numbers, your circled numbers, and put them under the radical in order from least to greatest. So my smallest number that's circled is 2, and there's 2 2's. So I'll say 2 times 2, and then I have 2 5's. If I want to check to make sure that my answer is correct, if I multiply all these numbers together, I should get 100. This is the prime factorization for 100. And that you should have covered 6th grade and a little bit of last year as well, okay? All right. The next step, and remember we'll write the steps down tomorrow, is since we're looking for the square root, we're looking for numbers under the radical that have a pair. Okay, we're looking for twins basically. And we have 2 sets. We have a pair of 2's and a pair of 5's. So we take 1 2 out to represent this pair, and we take 1 5 out to represent this pair. If it doesn't have a pair, leave it under the radical. There's nothing left under the radical here, so we don't even need the radical anymore. The numbers that are under the radical that are left there, we multiply together. The numbers that are outside of the radical, we multiply together. Nothing here to multiply, but here we can multiply these 2, and that gives us 10. So 10 is going to be our answer. Please make sure that you copy that. And tomorrow we'll write in the steps. Okay? Sure. Go ahead. Ask me a question. Mm-hmm. Yes. So when this was the factor tree initially, right? So when you draw a factor tree, um, you're breaking the number down to all prime numbers. So these are the prime numbers that this is broken down into. So 2 times 5 times 2 times 5 equals this 100. So you know you've completely broken it down when all of your numbers are prime numbers. So I couldn't stop at 10 because 10 is not prime. But I can stop here because all of these numbers are prime. Okay, because you're looking for the square root, you see how it's under the square root? Square root means that you're trying to find a number that can be multiplied times itself to give you the number under the radical. So you're looking for pairs because it's square root. So since you have one pair, for every one pair that you have, you take out that number. Just like remember with the square root of 25, it's 5 and 5. Well, your answer here is just going to be 5. It's not going to be 5 times 5. It's just going to be 5. You're welcome. All right, guys, I'm going to stop the video here and we'll finish where we left off tomorrow, okay? Have a wonderful day.